Graphing linear inequalities in two variables. So previously you've learned how to graph linear equations in two variables using slope and y-intercept and using the x and y-intercepts. So let's just review that. Use slope and y-intercept to sketch the graph of 2x minus 3y equals 12. So if you remember, we need to go into slope y-intercept form, or the form y equals mx plus b. So let's rearrange this. Negative 3y is negative 2x plus 12. Dividing through by negative 3, y is 2/3 x minus 4. So our slope is 2/3, and our y-intercept is negative 4. So how do we graph? Well, we go down and we start at a point, negative 4. And we use the definition of slope, 2/3, rise over run, go up 2, go right 3. There's our next point. Go up 2, go right 3. There's our next point. Now thinking of the slope as a positive slope, 2/3, it's up and to the right. We can also think of it as negative 2 over negative 3. So go down 2 and go left 3. And there's another point. And what we want to do is join those points with a straight line. I'm going to pause and go find the line tool and put a nice straight line through those. And there, as if by magic, I've used the line, drawn a straight line, and you'll note the two things that you have to have. It goes through the points, and of course we need arrows on both ends to indicate that this is a line. Okay, next, number 2, use the x and y-intercepts to sketch the graph of 3x plus 4y is equal to 12. Okay, x-intercept. Well, the x-intercept occurs when y is equal to 0. So substitute y equals 0, or 0 for y. So 3x plus 4 times 0 plus 12 equals 0. 3x plus 12 equals 0, and x equals, well, let's do 3x is negative 12, x equals negative 4. So I have my x-intercept. X is negative 4. I'm going to go and graph that. Negative 4. I suppose I should use a different color for this one probably. And the y-intercept. Y-intercept, you substitute 0 for x. Y-intercept occurs when x is 0. 3 times 0 plus 4y plus 12 equals 0. 4y is negative 12. Y is negative 3. Okay, let's go graph. Y is negative 3. Oops, I'm going to try and get a different color here. Pen tools. Color. Oh, let's go with blue. Okay, now I gotta find my pen. Okay, negative 4, 0, and the y value is negative 3. Which is down here. And we're going to join those 2 points. In this case, we only have 2 points. When I'm graphing with slope-intercept, I always like to show as many points as I can on the grid. Here we have 2 points. I will pause and draw us a nice little line. Okay, and the same thing. So we've drawn the line with 2 points. Let's label the equations for these lines, which means I need my pen back. So this, the first line we drew, is 2x minus 3y equals 12. And the second line we drew is 3x plus 4y plus 12 equals 0. Okay, so this is just a review of drawing a straight line. linear inequalities in two variables. Since the equation of a line can be expressed by the linear equation ax plus by equals c, if we replace the equal sign with the symbol strictly less than, strictly greater than, less than or equal to, or greater than or equal to, then a linear inequality is formed. A linear inequality can be expressed in one of the following four forms. Ax plus by is strictly less than c, ax plus by is strictly greater than c, ax plus by is less than or equal to c, ax plus by is greater than or equal to c, where a, b, and c are all real numbers. The graph of the line ax plus by equals c divides the coordinate plane into regions, one above the line and one below the line. For one of the regions, the statement ax plus by is strictly less than c is true, and for the other region, the statement ax plus by is greater than c is true. And the statement ax plus by equals c is true just for the line. The set of points that satisfy a linear equality can be called the solution set or the solution region. Below is the graph of the line y equals 2x minus 3. In the table is a list of points that are either on the line, above the line, or below the line. So we're going to go complete the table. So the first point is 2, 1. Let's go find that point on the graph. 2, 1 is right here, and that point is on the line, so we know that 1 is equal to 2 times 2 minus 3. The point negative 3, positive 1, that point is here. That point is above the line, which means that this equation, that point is greater than 2 times negative 3 is negative 6, minus 3 is negative 9, and negative 1 is greater than. The point 5, negative 6. 5, negative 6 is below the line. So this y value is less than. The point 4, 2 is below the line. So that point, that y value is less than the y value of the line at the point when x equals 4. Negative 2, negative 7. That's on the line. In that case, negative 7 is equal to. And the point 0, 0, the origin is above the line. So 0 is greater than. It means the y value of the point is greater than the y value on the line for the given x value. So let's use the findings from the table to complete the following sentences with one of the following statements. If the point xy lies on the line y equals mx plus b, then the point xy satisfies the statement that y is equal to mx plus b. If the point lies above the line, then the statement will be that the y value is greater than mx plus b, and if the point is below the line, then the y value will be less than the point on the line, which is y equals mx plus b. In other words, all the points that satisfy the inequality y is greater than mx plus b must lie above the line, and all the points that satisfy the inequality y is less than mx plus b must lie below the line. Okay, let's try a few of these. Number 1, so what we need to do is graph. We're going to graph using either slope-intercept or the intercepts, and we'll have to decide, is 2x plus 3y less than or equal to 6? Where do we draw this? Which region do we shade? Okay, starting with number 1. So let's rearrange. 3y is less than or equal to negative 2x plus 6. Y is less than or equal to negative 2/3 x plus 2. So if I want to graph this line, I have a y-intercept of positive 2. I have a slope of negative 2/3, rise over run, go down 2, right 3. Go down 2, right 3. I like to put as many points as I can, so I can also think of this as positive 2 up 2 and left 3. Positive 2 over negative 3. Go up 2, go left 3. Now, since this is a greater than or equal to, I am going to draw a solid line, and I'm just going to pause and go draw that line. When I was drawing the line on there, I noticed that I had placed this point in the wrong spot. It should be here. Whoops, and now I've moved the line, and I've got to go back and get my pen back again. So that point should be here. And that's one of the things about putting a lot of points on, is that you can make sure that your points are in the right place, because they should lie on a straight line, and that particular point didn't. So now what we have to decide is, where do we shade? We know that all of the y values in the region we want have to be less than or equal to this, which is the line. So I have a solid line that's equal to the line, and I need to shade below. So what I'm going to do is find my pen tool, and I'm going to try this with a highlighter. And I'm going to shade below the line. I'm going to highlight that area. So this is the region, the yellow region, including the line, is the solution region. Okay, and I should fill that in, but that'd take a little bit of time, and I have a little bit of leakage, so I need to go erase that little bit there, and there we go. So that's our solution region. Now, you can do this on your graphing calculator, and you can also do this in Desmos. So what I'm going to do is I'm going to pop over to Desmos, and we'll take a look at y is less than or equal to negative 2/3 x plus 2. So let me just go back and change this. So I'm going to go less than or equal to, negative 2/3 x plus 2. And you notice how we have the line. We've shaded the region below. We have a couple of points on the line. We also could have graphed this with intercepts. And this graph should resemble the graph that we have over here. Now another way, I'm going to bring up the okay, let's graph this on the calculator as well. I'm going to y equals, and I'm going to type in negative. I like to bracket my fraction, so 2 divided by 3, close bracket, x plus 2. And if I graph that, then what I'm graphing is y is equal to negative 2/3 x plus 2, again matching with what we have there. And I can go here, and if we arrow over to the left and keep hitting enter, you'll see how we move through different regions here. This is make a thick line. That's shade above. This is shade below, which is what we want. And so I'll hit graph. And the calculator will graph our inequality shading below. Now the only thing is it won't distinguish between a less than or equal to and a strictly less than. But that's a way that you can use the graphing calculator. And back to y equals. If we continue through these options, they're just drawing options and tracing options and drawing a dashed line in that and a fuzzy line. But shade above, shade below is what you would use on one of these calculators for graphing inequalities. Graph 2x minus 3y is less than or equal to 6. Same way, same inequality using the slope and y-intercept. Okay. Oh, not the same inequality. This is minus and not plus. So again, let's work this out. So first thing, I'm going to have negative 3y is less than or equal to negative 2x plus 6. Now I'm going to divide both sides by negative 3, but this is an inequality, and we have to remember that when you divide both sides of an inequality by a negative, you have to reverse the inequality sign. So this becomes y is greater than or equal to positive 2/3 x minus 2. Okay, again, to graph now, I go to my y-intercept minus 2. I use my slope, which this time is positive 2/3, go up 2, 1, 2, 3 to the right, 1, 2 up, 1, 2, 3 to the right. And I could also treat this slope as a negative over a negative, so I go down 2, 1, 2, 3 to the left, go down 2, and 1, 2, 3 to the left. And I'll go away and I'll draw a straight line. So I draw my line, which fits a little better, and now I'm going to shade above, since y is greater than or equal to, I want to be shading this area above. And since it's greater than or equal to, it also includes the line, so that's why we have drawn a solid line to show that it's greater than or equal to. And now I've got to fix the little glitch below. Whoops, that erased everything, but we know that it was. All right, let's undo that. Oh, interesting effects. Okay, you've got the idea, and we shouldn't have this thing below. So let's move on to number 3. Okay, last one. Graph 3x minus 2y is less than 12 using x and y-intercepts and a test point. Okay, so x and y-intercepts. So to find the x-intercept, so x-intercept means that we set y equal to 0. That'll give us 3x minus 2 times 0 is less than 12. Now in this case, really we want the line, so instead we're going to graph 3x minus 2y equals 12. We need to find points on the line. So let's make this equals 12. So 3x equals 12, x equals 4 is a point on the line. So we have 4, 0 is a point on the line. For the y-intercept, we set x equal to 0. So 3 times 0 minus 2y equals 12, because this time I want the line. Negative 2y equals 12. Y is negative 6. So the y-intercept of negative 6. Now when I draw the line this time, I'm going to draw a dashed line because the line is not included as part of the solution set. It's 3x minus 2y is strictly less than 12. So I'm just going to draw a dashed line. Okay, so this time I have a dashed line drawn through there to indicate that the line is not part of the solution set, but which region is the solution region? Is it above or is it below? Well, the only way for us to know, since we're not in slope-intercept form, where we have y is greater than or equal to, or y is less than or equal to, is that we have to pick a test point. And I like the point 0, 0. So either 0, 0 is part of the solution, or it isn't, just as we did in the table on the other page. So let's find out. Is 0, 0. So test point 0, 0. So we've got 3 times 0 minus 2 times 0 is less than 12, which is 0 is less than 12, which is true. And that means the test point is in the solution region, and so I'm going to highlight above. So let me go up and get my highlighter, and we'll come back over and highlight the region above. Oops. And to the left and to the right. So in this case, we needed to do a test, a test point to determine whether we should be shading above or below the line. We have a dashed line to indicate that the line is not a part of the solution and that all of the points in this region will in fact satisfy the inequality 3x minus 2y is less than 12. Okay, to finish off, when sketching an inequality that has the symbol less than or equal to or greater than or equal to, draw a solid line. When sketching an inequality that has the symbol strictly less than or strictly greater than, draw a dotted line. Write an inequality in the form ax plus by is less than or equal to c that represents the graph shown. In this case, really what we need to do is figure out the equation of this line. And so the characteristics, well, we have a y-intercept of 6. And the slope I can get just by counting. So let's find another point on the line. How about here? And we can see that to go from here to this point here, I'm going to go 1, 2, 3 down, 1, 2, 3, 4 to the right. So my slope is down 3, 4 to the right, or negative 3/4. The inequality will be y is less than or equal to, I guess they want this to be a solid line, although it looks like a dashed line. Y is less than or equal to negative 3/4 x plus 6. I want it in the form ax plus by equals 6. I'm going to multiply through by 4 to get rid of any fractions. 4y is less than or equal to negative 3x plus 24. And I'm going to bring this over. So 3x will become positive 3x. And we've got a plus 4y less than or equal to 24, which to me means that this needs to be a solid line and not a dashed line. Whoops. So that should be a solid line. Okay, and last one. Well, actually second last one, because we apparently have number 6 to do, which is the page 470 example 4. Algebraically determine if the point negative 2, 4 is part of the solution. Well, how do we see if a point is part of the solution? We substitute it in. X is negative 2 plus 3, and y is 4. And is that less than or equal to 6? We're either going to get a true statement, it will be true, or it will be false. Negative 4 plus 12 is less than or equal to 6. 8 is less than or equal to 6. That is false. False. And so the answer is no, it is not part of the region. Okay, to finish off, you want to look at the example on page 470, example number 4 in your textbook. That just gives an example of solving an inequality for a real-life type of situation. In this case, constructing a tabletop and the amount of money you have to spend. So take a look at the ideas in there, defining the variables, setting up the inequality. Also remember to look at the key ideas on page 471, which will summarize what we've done today.